10 CSMCG, and in this video we're going to be talking about the principle of conservation of charge. Okay, so let's first begin with the principle. Now the principle states that the net charge of an isolated system remains constant during any physical process. Remember, what is net charge? Net charge is the adding of all the charge. Adding of charge. That is net charge, or it could be total charge. That is what we call net charge. Okay, so have that in mind. Now, any physical process, let's say we have two object charge. This is object A, which is have a charge of 3 nanocoulombs negative, and this is object B, which have a charge of positive 2 nanocoulombs. Okay, so if we calculate the total charge of the whole system, the system is the two objects together. This is our system. This is the system, the two objects. All right, and they are close, only those two objects. We're going to focus on those two objects. That means isolated. So nothing else is important but object A and B. All right, now the total charge is going to be minus 3 plus 2. You have to add and you have to respect the signs of each charge. Okay, so we have minus 3 plus 2. The total charge is minus 1 nanocoulomb. Okay, now let's say we take those two objects and they are going to touch each other. What is going to happen? When they are touching each other, remember the triboelectric charge is the way of charging objects by touching each other. The electrons are going to be transferred. They are going to transfer. Now, they will go from object A. Remember, the first one was object A. This one was A, and this one is B. Now, the electrons will move from object A to object B. Why are the electrons moving from A to B? Because object A is more negative than object B. These are electrons. It doesn't mean that 4 electrons are going to move. It means that they are going to move. It doesn't mean that 4 electrons are moving. So now the electrons are going to move. They're going to rearrange, and we're going to have a new total charge. So here we still have A and B. Now what happened? The charges change. Okay, how do we calculate the total charge, the new charge? Now the new charge is going to be equal to the addition of the charge divided by 2, because there are two objects involved. All right, so here if we add the charges, that was going to be minus 3 plus 2 divided by 2. So what is the answer here? Minus 3 plus 2 divided by 2. The answer is going to be 0.5 nanocoulomb. This is the answer. So each of them will have a charge of 0.5 nanocoulomb. The charge here is 0.5 negative. Negative. Minus 0.5 nanocoulomb minus 0.5 nanocoulomb. Now, let's go back to the process. They say the total charge, the isolated system remain constant. The total net charge must remain constant. Remember, at the beginning we have a charge of minus 1 Newton. How much we have at the end? Total charge Q net must be equal to 0.5 negative. Let's fix that one. It's minus 0.5 plus minus 0.5. That is equal to minus 1 nanocoulomb. Nanocoulomb. So it shows you that the total charge is constant. So here you can see how to calculate the net or the new charge on objects when they are in contact with each other. This is all about the principle of conservation of charge. The video is quite short. I hope you understand. Next time we'll go to a charge quantization. It's a new topic, and this one is related. You need this one for quantization of charge. This is the way of calculating the new charge. We have two objects, they are in touch with each other, and that is the principle of conservation of charge. Thank you very much for watching, and up to next time.